Hello students, good afternoon. You are welcome in the lecture number 7 of MHTCET of a chapter of chemical thermodynamics. In the lecture number 6, we have seen first law of thermodynamics, internal energy, and then the relationship between first law of thermodynamics and different type of the processes. And then we have seen certain numerical examples based on calculation of internal energy, heat and work done using the mathematical equation of a first law of thermodynamics. In this lecture, we have to focus on another thermodynamic function known as enthalpy. Here we are focusing on a thermodynamic state function known as enthalpy. So let us see what is meant by enthalpy. We know that chemical reactions are carried out at constant pressure with a change in volume. During the chemical reaction, volume either increases or decreases, but the reactions are carried out almost at constant pressure. So the effect of constant pressure and a change in volume is studied with the help of a thermodynamic state function known as enthalpy. This enthalpy is given by the equation H will be equal to U plus PV, where we know that U is internal energy of the system, PV is also energy available to do PV type of the work. The summation of internal energy and PV type of energy is known as enthalpy. We know that internal energy is also known as energy not available to do work. This is the energy which is not available to do work, and this is the energy available to do work, and the summation of unavailable and the available energy to do work is known as enthalpy. We know that internal energy U is a state function, pressure P and volume V are also the state functions. Therefore, enthalpy H is also a state function. Therefore, change in enthalpy can be calculated simply by one equation. Suppose U2 is internal energy in final state of the system, U1 is internal energy in initial state of the system. U2 minus U1 is known as delta U. That is change in internal energy, which is a state function. Similarly, change in pressure delta P is nothing but pressure in the final state minus pressure in the initial state. Change in volume delta V is the volume in final state minus volume in initial state. Since all these three are state functions, they are calculated in terms of their change. Similarly, enthalpy H is also a state function, and that is calculated using this type of equation. Delta H is equal to H2 minus H1, where H2 is enthalpy in final state of the system and H1 is enthalpy in the initial state of the system. Now, how to calculate the enthalpy change using this equation? Let us consider U1 is internal energy in initial state of the system, pressure P1 and volume V1 in the initial state of the system. Therefore, from this equation U1 plus P1 V1 will be equal to, what is it, H1, enthalpy in the initial state of the system. Similarly, for final state of the system, internal energy U2 plus P2 V2, and this is equal to H2. Enthalpy in final state of the system is equal to internal energy in the final state plus pressure and volume in the final state of system. And from these two equations, since we know delta H is H2 minus H1, substituting for H2 and H1, what is H2? H2 will be U2 plus P2 V2 minus H1, minus H1. What is H1? U1 plus P1 V1. Here U1 plus P1 V1. Now solving that bracket, delta H is equal to U2 plus P2 V2 minus U1 minus P1 V1. Bracket I have solved. Now taking similar terms on same side, taking similar terms together, we can write delta H is equal to U2 minus U1 plus, what is it, P2 V2 minus P1 V1. Now I have told here that the chemical reactions are carried out at constant pressure, not at constant volume. The reactions are carried out at constant pressure. Therefore, pressure in the initial state of system P1 is equal to pressure in the final state of the system P2, or let us consider that is equal to P. So, what this equation now become? It is delta H is equal to U2 minus U1, then plus P2 and P1. They are replaced by now P. So in another bracket, this is PV2 minus PV1. Now taking common over there. What is common in this bracket? Pressure. P is common because that is constant, they are same. So this equation now will become delta H is equal to U2 minus U1 plus P in bracket V2 minus V1, and U2 minus U1, what is it? Delta U. V2 minus V1, what is it? Delta V. Therefore, finally this equation will become delta H is equal to delta U plus P delta V. This is the equation for enthalpy change during a chemical reaction. This is the equation for enthalpy change during that process. So this is about enthalpy change. Now using this enthalpy change, we have to see what is the relationship between heat of reaction, that is delta H, and internal energy of the reaction delta U, enthalpy of reaction at constant pressure, enthalpy of reaction at constant volume. For a chemical reaction, this relation now we have to derive. Now let us see that equation, the relation between delta H and delta U for a chemical reaction. Relation between delta H and delta U for a chemical reaction. Just now we have studied delta H is equal to delta U plus P delta V. go slightly back to the back steps. Before this, we have studied delta H is equal to delta U plus P. Delta V is nothing but V2 minus V1. Go one more step back, one more step. Delta H is equal to delta U plus PV2 minus PV1. Now, for an ideal gas, we know that PV will be equal to nRT. Here, n is number of moles of gases, R molar gas constant, absolute temperature, volume of gas, and pressure exerted by the gas. This is ideal gas equation by combining Boyle's law and Charles law. For PV2 final state and for initial state, for this equation become PV2 will be equal to N2RT. Similarly, PV1 in the initial state N1RT. Substituting for PV2 and PV1 from these two equations. So what we can write? Now here delta H will be equal to delta U plus PV2 replaced by N2RT and PV1 replaced by N1RT. So N2RT minus N1RT. Therefore, delta H will be equal to delta U plus, here what is common? RT is common, into bracket N2 minus N1, or simply delta H is equal to delta U plus delta NRT. Here at your 11th standard you have studied that delta N is change in number of moles in a chemical reaction. Here only gaseous state reactants and gaseous state products are considered. It is N2 in gaseous state, that is number of moles of product in the gaseous state, minus N1 number of moles of reactants in the gaseous state. See, this is important point. Delta N is a change in number of moles during chemical reaction. That is the difference between number of moles of gaseous product minus number of moles of gaseous reactants. Delta H is known as heat of reaction at constant pressure according to first law of thermodynamics that we have studied. Delta H is known as heat of reaction at constant pressure. Delta H will be equal to Q at constant pressure, and delta U is known as heat of reaction at constant volume. Delta U is heat of reaction at constant volume. Therefore, delta H replaced by QP, delta U replaced by QV, and this equation we can write QP is equal to QV plus delta nRT. This is the relationship between heat of reaction at constant pressure and heat of reaction at constant volume for a given chemical reaction. Here important point we have to note is that delta N is change in number of moles of gases during a chemical reaction where reactants and products are considered in the gaseous state. Number of moles of reactant and product which are present in gaseous state, only those are taken into consideration for calculation of delta N. So this is there about relation between delta H and delta U for a chemical reaction. Now let us see how to calculate the work done during a chemical reaction. calculate the work done during chemical reaction, that type of problems are there. So work done during process is different. Work done during process is different and work done during chemical reaction is different. That expression of work done during process is converted to work done during chemical reaction. So let us see that equation. What is work done during process? dW is equal to minus P delta V. dW is equal to minus P delta V. P external delta V. This is the equation we are studying since start of this chapter. dW is equal to minus P delta V. And just now we have elaborated dW will be equal to minus P. What is delta V? V2 minus V1. On solving this, it is dW is equal to minus. What this become? It will be PV2 minus PV1. Minus sign I have taken as it is. Minus, solving the bracket, here it is PV2 minus PV1. Just now we have studied PV is equal to nRT, therefore PV2 is equal to N2RT and PV1 is equal to N1RT. Here N1 is number of moles of reactant in gaseous state. N2 is number of moles of product in the gaseous state. So substituting these equations over here, this equation now become dW is equal to minus, this is negative sign, PV2 N2RT, PV1 N1RT. So N2RT minus N1RT. Again, what is constant, what is common in between these two terms? RT. So minus RT in bracket N2 minus N1. Therefore dW will be equal to minus N2 minus N1 is delta N RT. Here negative sign. Just now before this we have studied one equation. What is that equation? Delta H is equal to delta U plus delta N RT. Or this is also written as QP is equal to QV plus delta N RT. That is different. There is a positive sign. There is a positive sign. Whenever we are deriving, we are obtaining the relation between heat of reaction at constant pressure and heat of reaction at constant volume, there is a positive sign for delta nRT. But whenever we are calculating, we are deriving the expression for work done during chemical reaction, here delta nRT has a negative sign. This is important. In order to calculate the work done or in order to find out the relation between delta H and delta U, this is important, positive and negative. Now that is there about these two equations. Now the important point over here I am telling is that under which conditions delta H is equal to delta U and how to calculate delta N. That is the important point for a certain chemical reactions. See the conditions where delta H is equal to delta U. This equation we know, or this equation we know. We have to find out whenever delta H is equal to delta U. See, I am writing the equations once again. We have seen this equation, delta H is equal to delta U plus P delta V. The second equation, delta H is equal to delta U plus delta nRT, and third one it is QP is equal to QV plus delta nRT. One and same. This and this equation are same. Delta H is equal to delta U, or it is also termed as QP is equal to QV. We have to find out the conditions under which delta H is equal to delta U, or maybe QP is equal to QV. So what are the conditions under which this is true, that we have to find out. See here. If we see this equation number 1, delta H is equal to delta U, for that purpose this must be 0. When delta H comes equal to delta U, for that purpose this factor should be equal to 0 for a chemical reaction. But we know that chemical reaction has certain pressure, constant pressure, but not 0. Pressure is never 0. So how this will become 0? This becomes 0 whenever delta V, that is V2 minus V1, is equal to 0. It means that if volume in initial state of system and volume in final state of the system are same, at that time delta H is equal to delta U. It means that the reactions which are isochoric, to which change in volume is 0, they are having delta H is equal to delta U. We know that isothermal reactions are carried out at constant temperature. Isobaric reactions are carried out at constant pressure. Isochoric processes carried out at constant volume. So here for isochoric processes, change in volume is 0. Means initial volume is equal to final volume. Delta V is 0. This factor becomes 0 and delta H is equal to delta U. First condition. What else is possible over there? Where delta H is equal to delta U, this is first condition. Now second condition. See, this equation delta H is equal to delta U plus delta nRT. R is constant, certain temperature is there, but in delta N is 0. What is this total factor? It is equal to 0. So the reactions in which delta N is equal to 0 means N1 is equal to N2. The reactions in which change in number of moles during a chemical reaction is 0, or number of moles of reactant is equal to number of moles of product. This type of reaction has change in number of moles 0 and delta N is 0, therefore delta H comes equal to delta U. This is the second condition. Third condition, how we are calculating delta N? What is this? Delta N, how we are calculating the delta N? Delta N is equal to number of moles of gaseous product minus number of moles of gaseous reactant. Gaseous reactant and product are considered. So suppose if the reaction is carried out in liquid state or the reaction is carried out in solid state, what is delta N? 0. The reaction whenever carried out either in solid or a liquid state, at that time change in number of moles is 0 and delta H becomes equal to delta U. So these are the three important conditions under which delta H is equal to delta U. Now the important point I am telling here, to balance the combustion reactions. How to balance combustion reactions in order to calculate the change in number of moles during a chemical reaction. Balancing of combustion reactions. Suppose we have 1 mole of ethane gas, C2H6 gas. For combustion, we know it requires oxygen gas. Oxygen supports the process of combustion, and whenever the substance undergo burning, it produces carbon dioxide gas and H2O steam, that is liquid, usually liquid. This is the general reaction. Now balance it. How to balance it? See the rules. First rule is that, first of all, balance the carbon atoms from left to right. Balance the number of carbon atoms from left to right. So see, what is carbon atom number here? 2. How much here? 1. So this is multiplied by 2. Then second rule. Secondly, balance the number of hydrogen atoms. Again from left to right. Hydrogen 6. Here 2. Therefore, this is multiplied by 3. 3 2s are 6. And third rule, at last, balance the oxygen atoms but from right to left. At last, balance the oxygen atoms from right to left. 2 2s are 4 and 3 7. Here it is 2. 4 and 3 7. This is 2. So this must be multiplied by 3.5, or that is also written as 7 by 2. So 7 by 2 O2 gas. This is how we have balanced the reaction. Let us see one more example. Suppose we have this compound now, C6H6 benzene liquid plus O2 gas gives CO2 gas plus H2O liquid. Balance this reaction using these rules. First rule, balance the carbon atom from left to right. Secondly, balance the hydrogen atoms from left to right. And third, balance the oxygen atoms from right to left. So first of all, carbon from left to right. 6. Here it is only 1. So multiplied by 6. Second rule, hydrogen atoms. Again from left to right. Hydrogen 6. Here it is 2. So multiplied by 3. Now third rule, oxygen, but from right to left. Opposite. Right to left. Oxygen. 6 to the 12. 12 and 3, 15. 15 oxygen atoms. Means here it is only 2. So 2 multiplied by 7.5 will be equal to 15, or that is also written as 7.5. This here we have to multiply by 7.5, or can also be written like this, 15 by 2. So this is how the reaction can be balanced. Now to calculate the delta N for this reaction, what is delta N? Delta N is N2 in gaseous state minus N1 in the gaseous state. So N2 gas, only 2. This 3 is liquid. So out of consideration, we don't have to consider these 3 moles of H2O since present in the liquid state. Take only 2 moles of product in gaseous state minus. This is 1 mole gas and this is 3.5 mole gas. So 3.5 and 1, 4.5. Therefore answer is minus 2.5. This is how delta N is calculated. Similarly, for this reaction, how to calculate delta N final minus initial? These 3 moles, can we consider? No. They are present in the liquid state. So CO2 is gas, 6 moles of CO2 minus. This is liquid, benzene, not taken into consideration. Benzene, liquid, because state is given. If the gaseous is given, we have to consider, but liquid is given, so don't consider the liquid state. 6 minus 15 by 2 means 7.5, therefore minus 1.5. This is how change in number of moles can be calculated for any chemical reaction, and that is to be substituted while solving the problems. Now let us see certain number of multiple choice questions from the regular book which we are using. We are using the target book, target publication book, in order to solve the multiple choice questions. So first see the questions from classical concept, from the classical level. That is, we will start with question number, see, question number 42 onwards. See here the multiple choice questions from critical thinking, from first law of thermodynamics. Here we have studied the law of conservation of energy. Here we have to study the second law of thermodynamics, and in second law of thermodynamics, flow of heat can be studied. Flow of heat can be studied. Suppose if we have one bucket of cold water and one bucket of hot water, if we add cold water to the hot water, what happens? Whether temperature of hot water increases or decreases? Decreases. Now if we add hot water to cold water, opposite way, what happens? Whether temperature of hot water decreases or increases? Here also decreases. Whether we are adding cold water to hot water or hot water to cold water, every time we are observing that there is decrease in temperature of hot water take place. It means that flow of heat always take place from hot end to the cold end. Flow of heat always take place from hot end to the cold end spontaneously, means naturally. Or suppose, let us consider, suppose this is a piece of iron. If this is a piece of iron, if this end is heated, this is cold, I am heating at this end. Now what will happen? Whether heat will transfer from cold end to hot end or hot end to the cold end? It is hot end to the cold end, and that is known as second law of thermodynamics. Always flow of heat take place in a spontaneous manner, in unidirectional manner, from hot end to the cold end. And there is a certain perfect change taking place either in system or in a surrounding whenever the spontaneous process take place. That is the second law of thermodynamics. Now let us see multiple choice questions. Question number 42 from critical thinking. The spontaneous flow of heat is always, how the heat flow take place? Just now I have told you, heat flow take place spontaneously from hot end to cold end, that is from higher temperature to the lower temperature. See here, they have given 4 options. Option A is from low to high pressure. There is no question of pressure, so option A is wrong. Second option, from high to low pressure. Again they have taken pressure, so out of consideration. Third option, unidirectional from lower temperature to higher temperature. Flow of heat take place from lower temperature to higher temperature. Now they are telling, is it possible? No. It takes place from higher temperature to lower temperature. And last option is unidirectional from higher to lower temperature. So that is the correct option. Flow of heat always take place in a spontaneous manner, unidirectional manner, in only one direction from higher temperature to lower temperature. That is the second law of thermodynamics. Second, point out wrong statement in relation to enthalpy. See, the equation of enthalpy we have studied, delta H is equal to delta U plus P delta V. This is the relation, equation of enthalpy we have seen. Now see the four statements, and we have to identify wrong statement about enthalpy. Wrong. First one, decrease in pressure. See, point out the wrong statement from following in relation to enthalpy. Option A, it is a state function. Enthalpy is a state function. Is it true or false? True. Since internal energy change is state function, pressure is state function, volume is state function, therefore enthalpy is also a state function. This is correct. So this is not answer. We have to find out the wrong answer. So let us see the second option. It is an intensive property. We must know what is meant by extensive and what is meant by intensive. Extensive properties are the properties which are depending on amount of matter present in the system, and intensive properties are the properties which are independent of amount of matter present in the system. They have told over here it is an intensive property. Can you tell me, is it extensive or intensive? This is extensive. This is extensive because it depends on internal energy. Internal energy depends on the amount of matter present in the system. It depends on volume. What is volume? Extensive. Volume depends on amount of matter present in the system. Therefore, enthalpy is also extensive. But there they have given it is intensive property. So that is wrong statement. But here we have to find out the wrong statement. Therefore, this option is correct. For question number 43, option B is correct. It is intensive property they are telling, but it is actually extensive property. Option C, it is independent of path followed by the change. Correct. It is independent of path. This is a state function. State functions are not depending on the path. They are depending only on state, initial state and final state. Therefore, third statement is correct. Last one, its value depends upon amount of substance in the system. That is also right, because it is extensive property and its value depends on amount of matter, volume, internal energy. They are extensive. They are depending on amount of matter. So enthalpy also depends on the amount of substance present in the system. That is correct. Only second option is wrong. But here that is the correct option, because we have to find out the wrong statement. Now question number 44. For the two equations given below, these are the two equations given. For these two equations, we have to find out the correct relation between A1 and A2. See, first equation, H2 plus half O2 gas giving H2O liquid plus A1 kilojoule. For second reaction, H2 plus half O2 giving H2O gas plus A2 kilojoule. Now, can you tell me whether these two reactions are endothermic or exothermic? They are exothermic. exothermic, because along with the formation of these products, certain heat is also given there. Certain heat is also evolved over here. So both reactions are exothermic chemical reactions. For these two exothermic chemical reactions, here A1 is heat evolved, here A2 is the heat evolved, and we have to find out the relation between A1 and A2. Now let us see how to find out that relationship. For first reaction, calculate delta N. H2 gas plus half O2 gas giving H2O liquid. Delta H is equal to minus A1 kilojoule. Can you tell me why I have taken negative sign? Negative sign because heat is evolved. See here once again. Suppose these two are having 100 kilojoule of heat. This is having 90 kilojoule of heat. Plus A1 will be 10 kilojoule. This 10 kilojoule is given out. Therefore, delta H is having a negative sign, minus 10. This is also there. If these two are having 100 kilojoule, this is 90 plus A2, that is plus 10. This is also exothermic reaction. Calculate delta N. Delta N is N2 gas minus N1 gas. N2 gas is 0. This is liquid. So N2 gas is 0 minus N1 gas 1 and half. That is minus 1.5. So answer will be minus 1.5. For this reaction, we can calculate delta H is equal to delta U plus delta N RT, or delta H. What is the value of delta H? Delta H will be minus A1 is equal to delta U minus 1.5 RT. Right? Now see the second reaction. For second reaction, what is that type of relation that we have to find out? H2 gas plus half O2 gas giving H2O gas, and delta H is equal to now minus A2 kilojoule. For this reaction, delta N, N2 gas minus N1 gas. N2 gas is 1. N2 gas minus N1 gas. N2 gas is 1 minus N1 gas is 1.5. So answer will be minus 0.5. Delta H is equal to delta U plus delta nRT. So for this reaction, the equation become minus A2 will be equal to delta U minus 0.5 RT. Now this is equation for first reaction. This is equation for second reaction. Compare A1 and A2. Which answer is greater? This answer will be greater. Is it right? R and T is constant. R and T is constant. See, this is 100. This is also 100. Suppose, let us consider this is 100. Here also 100. 100 minus 1.5 RT and 100 minus 0.5 RT. Which answer is bigger? This answer is bigger. Minus A2 is greater than minus A1. See here, minus, see it critically. Minus A2 is greater than minus A1. And we have to find out the relation for plus. Therefore, plus A1 is greater than plus A2. A1 plus A1 is greater than plus A2 or A2 is less than A1. Now let us see four options. First option, A1 plus A2 is 0. That is not possible. Second, A1 is equal to A2. A1 is equal to A2. Never possible. Third, A2 is greater than A1. We have studied it opposite manner. And last option, A2 is less than A1. So last option D is correct. A1 is greater than A2 or A2 is less than A1. See, this is a critical thinking. If we see the negative signs, A2 will be greater. But we are studying it for a positive sign. Therefore, A2 is less as compared with A1. Now, let us see next question. That is question number 45. Now see question number 45. For the following reaction at 298 Kelvin, this is the reaction given. Which of the following is correct? They have given the options in terms of delta H and delta U. We have to find out the relation between delta H and delta U for this reaction. So we know the equation delta H is equal to delta U plus delta nRT. For this reaction, calculate delta N. Delta N is N2 gas minus N1 in gaseous state. So N2 gas is 0 minus N1 gas is 1.5 minus 1.5. Substituting there, what it become? Delta H is equal to delta U minus 1.5 RT. Now we have to find out the relation between delta H and delta U. Are they equal? No. For equal, this must be 0. So they are not equal because this is not 0. So they have given the first option delta H is equal to delta U. That is wrong because delta H is not equal to delta U since this is not 0. Now suppose if this is 100, see here, if this is 20, this answer comes equal to 20. What is this delta U? It must be 120. Is it right? Therefore, which one is greater now? Delta U is greater than delta H, or we can write delta H is less than delta U. So now see the options. Second option they have given delta H greater than delta U, that is wrong. Third option they have given delta H less than delta U, that is correct. Delta H is less than delta U. So third option is correct. For this question, option C is right. Now let us see next question. That is question number 46. For calcium carbonate, for this reaction, calcium carbonate solid giving CaO solid plus CO2 gas at 976 degrees Celsius. They have given delta H and we have to calculate delta U. Very simple. We know this equation. Delta H is equal to delta U plus delta nRT. Delta H they have given. Delta U we have to calculate. Temperature is given. R is constant. What is value of delta N for this reaction? Delta N is equal to N2 gas minus N1 gas. N2 gas is 1 minus. This we don't have to consider because this is 1 but it is solid. This is also solid, so not necessary to consider. 1 minus 0 is equal to 1. Delta N is 1. R is 8.31 for standard value. Temperature 977 degrees Celsius plus 273 Kelvin. So temperature will be 977 plus 273. It is equal to 1250 Kelvin. 730 7714 plus 115 and then 9 to 11 plus 1 carry, that is 12. 1250. Substituting here, what is the equation for delta U? Delta H minus delta nRT. Delta H given 176 kilojoule. R we are taking 8.314 joule. Therefore, delta H should be in the joule. 176,000 minus delta N. Delta N is 1. R 8.314. Temperature 1250. If we solve this and this factor minus this answer, see which one is bigger, we will easily come to know. Let us consider this is 1300 into 8. This will be equal to 9100 at the most. At the most 9100, 9100. So this figure is less as compared with this one. Therefore, answer is positive and less than this, less than 176. Therefore, option A and option B are out of consideration. Remaining is only option C or D. If we solve it correctly, we will get the correct option. Take log of these two terms, addition, then antilog, then subtraction. You will get the answer in joules. Convert it in the kilojoules. We will get the answer C. Correct option is C. That is 165.6 kilojoule. Now question number 47. For the gaseous reaction involving complete combustion of isobutane. Again find out the relation between delta H and delta U for complete combustion of isobutane. Butane. What is formula for butane? C4H10 gas plus O2 gas giving product CO2 gas and H2O liquid. Balance this reaction. How to balance this reaction? I have told you. First of all, balance the carbon atoms from left to right. So carbon 4, here it is 1 multiplied by 4. Now balance the hydrogen atoms from left to right. 10, 2, so multiplied by 5. And third rule, balance the oxygen atoms from right to left. 4 to 8 plus 5, 13. So this is multiplied by 13 by 2. That is 6.5. What is delta N for this reaction? N2 gas minus N1 gas. N2 gas is 4. This is liquid. Don't consider. So 4 minus. This is gas. This is also gas. 6.5 plus 1, 7.5. So answer is minus 3.5. Now find out the relation. Delta H is equal to delta U plus delta nRT. Substituting that, delta H is equal to delta U minus delta nRT. So now very simple. If this is 100, this is 10 minus. What is the answer of delta U? 110. Therefore, what is the relation? Delta H is less than delta U. And they have given 4 options. Out of that, option C is correct. Option C, in which delta H less than delta U they have given, that is correct. Now let us see question number 48. 48. Question number 48. A mixture of 2 moles of carbon monoxide and 1 mole of oxygen in closed vessel is ignited to convert to carbon dioxide. If delta H is enthalpy change and delta U is change in internal energy, then very simple, we have to find out the relation between delta H and delta U. 2 moles of carbon monoxide, 2 moles of carbon monoxide gas plus 1 mole of oxygen gas, 1 mole of oxygen gas, they are ignited together and they are converted to carbon dioxide. So it gives 2 moles of carbon dioxide gas, 2 moles of CO and 1 mole of O2. They will give 2 moles of CO2 gas. For this simple reaction, we have to calculate, we have to find out the relation between delta H and delta U. What is delta N? N2 minus N1. This is gas, gas, gas. So 2 minus 2 plus 1, 3. So delta N is minus 1. Relation delta H is equal to delta U plus delta nRT. Very simple. So delta H will be equal to delta U minus 1 RT or minus RT, and again in the simple manner 100 is equal to 110 minus 10. Therefore delta U is greater than delta H. The simple relation, they have given 4 options. First one, delta H greater than delta U. Second, delta H less than delta U. So second option is correct. Option B is right for this question. Now next question, in which of the following delta U is equal to delta H? I have told you the conditions for which delta H is equal to delta U. First condition, N2 is equal to N1. Number of moles of gaseous reactant must be equal to number of moles of gaseous product. Second, if the reaction is isochoric carried out at constant volume, delta V is 0, so delta H is equal to delta U. And third, if the reaction is carried out in liquid or solid state, at that time delta H is equal to delta U. So let us see the options. They have given 4 reactions. First reaction, N2O4 gas giving 2NO2 gas. N2O4 gas is equal to 2NO2 gas. Both side gases. See here, one of them I am explaining. N2O4 gas giving 2NO2 gas. For this reaction, delta N 2 minus 1, it is equal to 1. So delta H will not be equal to delta U. Delta N must be 0. Then and then only delta H is equal to delta U. But here not 0. So first option is not right. Second, 2SO2 gas plus O2 gas giving 2SO2 gas. There also delta N is minus 1 now, not 0. Third option, H2 gas plus I2 gas giving 2HI gas. Now this is correct. See the third option, H2 gas plus I2 gas giving 2HI gas. So delta N 2 minus 2, 2 minus 1 plus 1, 2. So delta N is equal to 0. If we substitute delta N 0, what is this total factor? 0, and delta H is equal to delta U. So third option C is correct. Option C is right, in which delta U is equal to delta H, where number of moles of reactant is equal to number of moles of product. Now question number 50. For this reaction, this is combustion of C6H12 giving 6CO2 6H2O. Delta H is given in kilocalorie or in kilocalorie. Temperature in Kelvin. Which of the following is true? So directly by substituting these values, obtain the relation. We know the equation, delta H is equal to delta U plus delta nRT. What is the value of delta H? minus 936.9 minus 936.9 kilocalorie equal to delta U. Delta U is not given, so let that delta U will be there as it is. It is not given. Plus delta nRT. What is delta N? How to calculate delta N? We know delta N is equal to N2 minus N1 in gaseous state. N2 6 minus 9. This 6 we don't have to consider. This one also we don't have to consider because they are liquids. So 6 minus 9 equal to minus 3. So delta N is minus 3 R 0.002 means 2 into 10 raised to 3. Temperature 298. So this is the answer. They have not given the solution. So let us see which is the equation given over here directly. Option C is right. Third option they have given. Option C, third option they have given in this format. It is not necessary to calculate the answer. Direct see the format and compare with the options. Third option C is given in this format. Now let us see some questions from classical thinking. Question number 32 onwards from classical thinking. See question number 32, direct a theoretical question. The second law of thermodynamics states that 4 options given. Already we have seen the statement that flow of heat take place in unidirectional manner, in a spontaneous manner, always from higher temperature to lower temperature, that is from hot end to the cold end. So here they have given third option C. All spontaneous processes are thermodynamically irreversible. They are taking place in only one direction. Irreversible, taking place in one direction. Unidirectional flow take place. So third option C is correct for question number 32. Now question number 33. Heat exchanged in chemical reaction at constant temperature and pressure is called, it is the definition of enthalpy. So for question number 33, directly option B is correct. Question number 33, option B. Why? Because what is question? Heat exchanged in chemical reaction at constant temperature and constant pressure is called as option B, enthalpy, definition of enthalpy. Then question number 34, in a reaction all products and reactants are in liquid. In reaction all the products and reactants are in a liquid state. So what is delta N? Delta N will be 0. If reactants and products are present in liquid or solid state, they are not considered to calculate delta N. So delta N for that reaction is 0, and whenever delta N is 0, we know that delta H will be equal to delta U. Therefore, out of the 4 options, third option they have given, delta H is equal to delta U. So option C is right. Then question number 35, enthalpy change does not equals internal energy change when enthalpy change and internal energy change are not equal, means delta H is not equal to delta U. So what are the conditions here? That whenever they are not equal, first condition, all reactants and products are in solution liquid, that time they are equal, not correct option. Second, reaction carried out in closed vessel, means no change in volume, isochoric, that is also not correct. Number of moles of gaseous reactant and moles of product are equal, at that time also delta H is equal to delta U. Reaction is carried out at a constant pressure. So option D over here is correct, because reaction whenever carried out at constant pressure, delta H is equal to delta U plus P delta V. At that time delta H is not equal to delta U. So option D is right for question number 35. Option D is correct. Now question number 36. Which is delta N for combustion of 1 mole of benzene when both reactants and products are gas? 1 mole of benzene. Calculate delta N. Benzene C6H6 gas plus O2 gas giving CO2 gas plus H2O also gas. All reactants and products they have told in a gaseous state in this problem. Usually H2O is liquid. Usually benzene is also liquid. But they have taken in the gaseous state to calculate delta N for 1 mole of benzene when both reactants and products are in gaseous state. Calculate the change in number of moles for this reaction. Balance the reaction. First of all carbon from left to right. So this is multiplied by 6 because 6 here 1 multiplied by 6. Then hydrogen 6. This is 2. So multiplied by 3. Now oxygen from right to left 12 plus 3 15. So 7.5. 15 by 2 or 7.5. Now calculate delta N. This 3 plus 6 9. This is gas, this is also gas. So 9 minus 1 plus 7.5. What is it? 8.5. So answer is plus what is it? 0.5 or plus half. Let us see the option. So they have given the option 0, 3 by 2, minus 3 by 2 and plus half. Therefore option D is correct for this question. Question number 37. Delta H and delta U for the reaction. They have given one reaction 2S solid plus 3O2 gas giving 2SO3 gas are related as. For this reaction, just calculate delta N. What is the value of delta N? And then substitute over there 2S solid plus 3O2 gas giving 2SO3 gas. What is delta N? Tell me directly. Product minus reactant, gaseous state, 2 minus 3. So delta N is minus 1. As delta N is minus 1, we know this equation. Delta H is equal to delta U plus delta nRT. This is minus 1. So delta H is equal to delta U minus 1 RT or minus RT. And here in this format they have given option C. For question number 37, option C is correct. So this is what we have studied about enthalpy and multiple choice questions from enthalpy and second law of thermodynamics. Next part we will see in the next lecture.